So now that we know that displacement, velocity, and acceleration are all related to each other by calculus, by derivatives, okay? V of t is the derivative of s of t, a of t is the derivative of v of t, and the double derivative of s of t. Now that we know that, let's interpret what motion is happening. What's happening to the motion of the particle? And remember, we're talking about the motion of a particle moving in a straight line. Okay, so we're going to use the information, the mathematics that we know, to describe what is happening to the point P as it moves along a line, maybe horizontally or vertically. Okay, specifically some things that we can focus on, or some things that we can notice by using our math is we can find out the position of P, we can find the direction of motion of P, so which way is it going, and where does a change in direction occur? So is it suddenly moving forward and then moving backwards? We can figure that out. Is it suddenly moving up and then coming back down? We can find out where that's happening. We can also find out where on what interval P is accelerating, okay, or where the velocity increases or decreases. So if the velocity increases, it's accelerating. If the velocity decreases, then it's decelerating or slowing down. Okay. All right. So let's take a look at the signs a little bit more closely. We've already talked about the signs of S of t. In the previous video, we talked about how when S of t is 0, that means the displacement is 0. And remember, displacement is how far the point P is from the origin. So if it's 0 units away from the origin, P is where? It's at the origin. It's at the point O. Okay? So P is at O in this case. If S of t is greater than 0, we said P is where relative to O. If it's a positive number, we said that P is going to be over on this side, so we say it's to the right of O. Okay? And if S of t is negative, it's going to be to the left of O. So we've already talked about these, right? This, again, S of t is displacement. It tells me the position. Okay? It tells me the position of the point P relative to O. Now let's look at the signs of V. Okay, what does V tell me? V tells me the speed and the direction. Okay, so let's look at the signs of the speed. If the velocity is 0, that means that P is doing what? What's happening to P if the velocity is 0? If I'm moving at 0 centimeters per second, I'm not moving, right? So P is not moving. P is what we would say is stationary. Okay? P is not moving. Now, does this mean that P is, if it's not moving, does that tell me anything about its displacement? No, P could be anywhere on this line, but if the velocity is 0 at that point, it's just at that instant it's not moving. Okay? So this when velocity is 0, it tells me that the point P is stationary, or instantaneously it's at rest, okay, or at rest. But it does mean that it doesn't tell me where P is. Okay? If velocity is positive, okay, P is moving to the, if we're talking about a horizontal line, it's moving to the right. Okay? It's moving in the positive direction. And that makes sense. If the velocity is positive, then we would expect P to be moving in the positive direction, which in this case would be to the right, since we're talking about a horizontal line. If V is negative, well, just like this top line, P is moving now to the left. Okay, so now let's think about this very carefully. Okay, if P is moving to the left, that means it's moving backwards. Okay, so whichever way is positive, if p is moving, if let's say p was moving this way, okay, suddenly the velocity goes to a negative number, it stops and it starts moving back. Okay, so this is describing motion. This is describing not position, but speed and motion. Okay, it's describing speed and direction. Okay, it tells me the motion of which way it's moving. All right. Now, what about A of t? A of t is acceleration. And it tells, since we know this is the derivative of this, it's telling me how fast my velocity is changing. So this tells me something more closely about velocity, but it also indirectly tells me something about the position, possibly. Okay? Or it helps me describe the motion. I wouldn't say it tells me anything about the position, but it tells me what's happening to p. Alright, so if A of t is 0, if the acceleration is 0, then that means velocity is doing what? Just like position is stationary, or the position is not changing, the velocity, when the acceleration is 0, is not changing. Okay? Now, if the velocity is not changing, okay, if the velocity is stationary, that means velocity is either going to be it's a critical point, right? So velocity is going to be a local maximum, local minimum, or it's just going to be constant. Okay? Possibly a point of inflection there. Okay? This is possibly constant. Okay? Possibly constant. And what is this telling me? Well, let's think about this in terms of p. What's happening to p if the acceleration is 0? If I am not accelerating, okay, if I'm in a car and I'm not pressing the gas pedal, could I still be, well, that means my velocity is constant, so my speed is not changing, but does that mean my position is not changing? Let's think about that. If the acceleration is 0, what does that tell me about, does that necessarily mean my position is staying still? No. I could still be moving at 100 miles an hour, not accelerating, so my speed is not changing. I'm constantly moving at 100 miles an hour, so my position could still be moving very much. Okay? So all this tells me is something about my velocity. The acceleration, when it's greater than 0, that means my velocity is increasing. Okay? So this is increasing, right? And that makes sense. Velocity is getting faster, okay, because my acceleration is getting faster. And my velocity is decreasing if my acceleration is negative, okay? So very, very important here to understand the signs of A of t and the signs of V of t. Okay, we've already talked about the signs of S of t. All right. Now, let me just explain again with vertical motion, what's happening. So I've drawn a graph here, and this is not in your textbook, but I just wanted to maybe clarify this for some of you. Okay, we've already talked about we know how to find the derivatives of curves and sketch them, right? First derivative and second derivatives. If I see a velocity graph, I can make some conclusions about what's happening. Okay, so let's see what's happening right here. I'm going to draw a motion graph, a vertical motion graph of what's happening in this situation. All right, at time t, my particle is here. As I get to about, I don't know the units of this, the scale of this axis, but it's going to move eventually to this point. Right? So it's going to move all the way up to here, and then it's going to start coming back. It's going to start coming back down. Notice here that the velocity is 0. So right at this point, my velocity is 0, which means that it's going to start changing directions. Okay, it's either a maximum, a minimum, or a constant. Okay, so it's when the velocity is 0, sorry, when the velocity is 0, the s of t is at rest. Sorry. Okay, so s of t is at rest right here, and then right at that instant it stops moving, and then it comes back down. Okay, and it comes back down to right about here again. Okay, so I'm going to draw a curve like that. So it goes up, then it comes back down, and then it goes back down all the way to here. Okay, down to this point. And again, you notice that at this point, it's going to start changing directions again. So it's going to start going back up. And so you see that the velocity is 0 again right at this point. Okay? And then it starts moving and it goes back up and it just keeps going up this way. Okay, so I don't know what kind of particle this is, but maybe it has a rocket booster and it goes up and then it fails and then it fixes itself and it just keeps going up. Okay? So something like that. But this is describing what's happening with the motion here. Okay, and you can see here that on this interval from 0 to this first point, the maximum here, that velocity is positive in this section. So if velocity is positive, that means the body, the particle, is moving in the positive direction. In this case, it's moving up. So this line right here, when it's moving up, the velocity is positive. And then as soon as it changes direction and starts moving back down, my velocity values are negative here. Okay? And so it goes up, it changes direction, my velocity is now negative. My velocity is negative, 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 getting more negative. Okay? And then it starts slowing down right around here. It starts slowing down. Okay? And then it goes back up. Okay? My velocity becomes positive again, so now it starts moving back up. Alright? So in this case, you can see here how the velocity is related to the displacement graph. Okay? And obviously here, the acceleration, because if I take the derivative of this function, I get a straight line. It looks like there's constant acceleration throughout this whole thing. Okay? Alright? So hopefully that makes a little bit more sense by looking at this. Alright, here are some key words and phrases that you might see come up in the word problems. Okay? Initial conditions means what? It just means that time is equal to 0. Okay? At time is 0, what are the initial conditions? If I say, what are the initial conditions? Okay, describe the motion for me when time is 0. That's what it's saying. Okay, what is S of 0? What is V of 0? What is A of 0? That's really what it's asking for. If I say something is at the origin, if I say the point is at the origin, what does that tell me? Well, that means that S, my displacement, is 0, isn't it? Okay. If a point is stationary, if it's not moving at a certain point in time, what does that tell me? It doesn't tell me anything about the displacement. It doesn't necessarily tell me what time that is, but it does tell me that the velocity at that point is going to be 0. Okay? If a body reverses direction or it changes direction all of a sudden, what else does that tell me? It doesn't tell me the time, it doesn't tell me the displacement, but it does tell me that the velocity is going to be 0, possibly, okay? But in this case, the velocity must change sign. Velocity must change sign. Oh, sorry about that. Okay, must change sign. Okay, and we talked about that up here, how it changed sign. It was positive. The velocity was positive here. As soon as it changed sign, the body started moving back down. Okay. Maximum or minimum displacement. Again, that would be when velocity is 0, and again the velocity must change sign here. Okay. In this case, we had two situations. We had the negative here, the minimum, and the maximum, and in both those cases, the velocity was changing sign there. If I have a constant velocity, what does that tell me? It doesn't tell me anything about the time. It doesn't tell me anything about the displacement. It doesn't tell me anything about the velocity. Well, yeah, it doesn't tell me the specific value of the velocity, but it does tell me that the acceleration is going to be 0. The velocity, because it's staying the same, that means the rate of change of the velocity, the instantaneous rate of change of the velocity, which is this, right? dv dt or v prime, the rate of change of the velocity is not is 0. It's not changing. Okay? And then if I have a maximum or minimum velocity, well, again, we can assume that probably a is going to be 0, but you need to check the sign diagram. Okay? You need to check the sign diagram of what? The sign diagram of a. Okay? So if I see a change in sign there, then I know that velocity is going to have a maximum or minimum. Right? Okay, for speed, let's talk about speed here. How is speed different from velocity? Well, velocity has a magnitude and direction. Speed is just a scalar quantity. And so it just tells me how fast an object is moving regardless of the direction. It's scalar. I don't care which direction it's going. Okay, if I'm going in my car, if I'm moving in my car, if I go forwards or backwards, the speedometer on my car is not going to show me the direction. It's not going to say I'm moving in negative 10 kilometers per hour, right? It just tells me how fast I'm going. So really, the speed is just the absolute value of the velocity. Whatever the value is, just make that positive, and that is the speed. Okay? Here's a note about interpreting when speed is increasing or decreasing. If the velocity and the acceleration are both positive, so if I have a positive velocity and a positive acceleration, then the speed will be increasing. Okay? The speed, the absolute value of the velocity will be increasing. That means the value of the number here will be growing. Okay? And that's also true if both velocity and acceleration are negative. Okay? So if the signs are the same, on a certain interval, then we can say that the speed of p is increasing on that interval. Okay? However, if they have opposite signs, for instance, if v is positive and a is negative, or v is negative and a is positive, then the speed of p is decreasing. Okay? So how fast it's moving is actually going to be decreasing. The rate of change of p, the rate of change of the displacement of p will be decreasing. Okay?